So we just have to turn in the first three things. We're doing
okay, here we go. Here we go. Number one. These first few we should be able to fly through. I think we'll have no issues with the first few. Okay, so number one, here we go. Now I can't find where I put my sheet. All right. Change to radians 28.12 degrees. Well, I'm just trying to be tricky there. This would be the setup, right? So you can use a calculator to help reduce that fraction, but essentially it's going to be 28.12 pi over 180, right? And you can use a calculator to help you reduce that fraction, because I don't know why I put a wacky decimal in there. I think just to throw you off. So in decimal form, it'd be 0.1562 repeating pi. In fraction form, it's 703 over 4,500 pi. Next one's the same thing. Pi is to 180 as 1.2 is to x. So I can use my calculator. I'm going to give you crazy numbers. I'm going to have to let you use the calculator. So x equals 216 over pi. And then one more. Oh, this one's easy. 2 pi over 9. You could go through this process, right? But you don't really need to, because we know pi is 180 divided by 9 is 20 times 2 is 40. So if you want to go through the process, you're going to get 40, but that one you can shortcut easily because there's a pi in it, and you know pi is the same as 180. All right, so that's not too bad. All right, find the value of all 6 functions. That means, remember, that we need the sine and the cosine and the tangent, and the cosecant, the secant, and the cotangent. So we've been given that triangle. All right, so here we go. How will I start that? Find the hypotenuse. We're not going to be able to fill all these blanks in if we don't have the hypotenuse. So what would the hypotenuse be? What?
Radical square root 13.
The square root of 13? So now we can fill them in. Now keep in mind, theta is here. So this side is the opposite. And this side's the adjacent, and this side's the hypotenuse. So now we can just use our SOHCAHTOA. This should not be hard for you. You should be able to zip through this. What's the sine? 3 over root 13, which will rationalize. Now, if the sine is 3 over root 13, then the cosecant would be root 13 over 3. Because they're reciprocals of each other. All right, what's the cosine? 2 over root 13, or 2 root 13 over 13. And if the cosine is 2 over root 13, then the secant is root 13 over 2. Tangent, 3 over 2, opposite over adjacent. So cotangent is 2 over 3. Easy. Number 5 is also easy, except you have to draw your own picture. So you got an angle that contains the point -3, 1. So the angle looks like this. The terminal side. Remember, this is the initial side. Every angle starts here. So we're looking at an angle that's over here, containing the point -3, 1. So what are we going to do? Make a triangle, butterfly bow tie. So we'll drop a perpendicular. DeAndre, you with us here? Okay. So I drop that right down. So this side, remember how you got that point? This side is -3 and this side is 1. And we can do exactly what we just did. Find the hypotenuse, which would be root 10, square root of 10. And then we fill in all the blanks. So we want, because it says find all 6. So here we go. Sine, cosine, tangent. And cosecant, secant, cotangent. Now, this is exactly the same thing, except you do have to watch out. We're going to have negatives. We're going to have some negatives in this part, right? Because of where that angle is drawn. So what's my sign? Yeah, it's 1 over root 10. Don't try to skip too many steps. It's 1 over root 10, which is root 10 over 10. And if the sine is 1 over root 10, then the cosecant is root 10 over 1, or root 10. How about the cosine? -3 over root 10. Or -3 root 10 over 10, adjacent over hypotenuse. And so what's our secant? Root 10 over -3. Tangent? 1 over -3 or -1/3. And that means the cotangent is -3 over 1 or -3. Right? Those are easy if you have all your stuff memorized. I mean, obviously you gotta know SOHCAHTOA. But otherwise that's easy. Number 6, we actually already did one, and some of you had this on your quiz. We want to find the length of the arc determined by an angle of 18 degrees in a circle with a radius of 6. So we remember what? We got to find the length of the arc. So we immediately think arc equals? Yeah. Radius times radians. I love it when you talk that way. Good job. Now, we need to find our angle in radians because it's been given in degrees. So we know how to do that. This is not a bad one at all. So pi is to 180 as something is to 18. So it looks like that angle, when I reduce it, is pi over 10. Is that okay with everyone? So what do I do now to get my answer? I gotta multiply 6 times pi over 10. Which would be 3 pi over 5, is that right? And again, if this this is feet, then this would be feet. Whatever the unit is of the radius is going to be the unit of the arc length. Yeah, I feel like this is pretty manageable so far. Let's see what comes next. Find the exact value. That means don't just type it into the calculator. Find the exact value of the cosine of 120 degrees. So, how do we start that? Draw a picture of it. 120 degrees is over here. Drop it. Then we got to do, this is the key, you got to find that angle right there. That's the angle you always want, the one inside the triangle at the origin. How big would that one be in this case? 60. And the minute you say that's 60, then you know this is root 3, this is 1, and this is 2. Then we stop and say, okay, do I have anything that's negative in my picture? 1 would be negative, because it's in quadrant 2. And I want the cosine. Cosine is negative 1 over 2. There it is. There's the cosine of 120. Now we're going to find the tangent of pi over 4. All right, I think you can do that. What's the tangent of pi over 4? Oh, first of all, what's pi over 4? 45. We know it's 45 because pi is 180, and 180 divided by 4 is 45. So we'll do exactly what we just did. Got a nice little 45-degree angle in quadrant 1. And of course, the minute I draw the 45, I then know 1 root 2. And I want the tangent. So the tangent would be opposite over adjacent, so that would just be 1. Secant 4 pi. How many degrees is 4 pi radians? I think that was a question on one of the quizzes.
360.
No, it's not 360. 720. Yeah, it's 4 180s. So we're finding the secant of 720. Now, for purposes of this problem, not the one on the quiz, but for this problem, if you accidentally said 360, you'd still be okay, because what happens when you draw, that's our next step, we're going to draw it. What happens when you draw a 360 and you draw 720? Don't they end up in the same spot? They're what we call coterminal angles. So this is 720, but no matter whether, even if you screwed up, you're still going to be right here, right? Now, this problem is different. I'll make that a little bigger. This problem is different because the angle is not sticking out in a quadrant like this one was. The angle is actually on an axis. And when it's on the axis, I can't use my opposite over adjacent. Those are called the triangular definitions. The sides of the triangle, opposite, adjacent, hypotenuse. I have to use the circular definitions. What are the circular definitions? Y over R, X over R, Y over X. If you're on the circle, you got to use those definitions. So what are the coordinates of this point right here? 1, 0. So X is 1, Y is 0, and R is 1. The radius of that circle is 1. Secant, reciprocal of cosine. Cosine, X over R. So secant would be R over X. And if I put R over X, I get 1. These are the ones, remember, that come out undefined sometimes, because it's possible that you have a 0 in your denominator. We didn't. We got 1. tangent, pi over 2. We're finding the tangent of 90. Agreed? Now 90, where's 90? It's not sticking out in a quadrant. 90 is right here, isn't it? So it's on the circle again. So I'm going to use the coordinates of that point to answer the question. X is 0, Y is 1, R is 1. Those are the values at 90. Everybody with me? I want the tangent. The definition of tangent is y over x. Y over x. Uh-oh, y over x turns out to be 1 over 0, which is undefined. And that makes perfectly good sense, because when you sketch a tangent, a regular tangent curve, here's pi over 2, and what's happening at pi over 2? An asymptote. You have asymptotes whenever you are undefined. At 90, or pi over 2, the tangent is undefined. Sine negative 135. All right, this one's a little different because you have a negative angle. How does that change things, having a negative angle?
You go down.
You go the other way. So negative 135 would be over here like this. And then we gotta find this all-important angle right here. That would be 45, which means 1 root 2. And then I say, okay, do I have any negatives? Both ones are negative. Remember, your radius is never negative. The hypotenuse is never negative, but both ones are, because I'm in quadrant 3. I want the sine. Sine is opposite over hypotenuse. Negative 1 over root 2 or negative root 2 over 2 is our answer. All right, one more of those, and then we're on to the next thing. Cosecant 7 pi over 4. Hmm, 7 pi over 4. 180 divided by 4 is 45 times 7, 315. Positive, so I'll draw 315. It's down here in quadrant 4. Reference angle, 45. So I got another 1 root 2 situation. Anything negatives there? The one that goes down. And that's why it's negative, because it goes down. Cosecant, reciprocal of sine. The cos never go together, so cosecant's got to go with sine. Reciprocal is sine. Sine is opposite over hypotenuse, so this would be hypotenuse over opposite. So root 2 over negative 1 or negative root 2. Any questions about that section? Number 8. If the sine is negative 3/4 and 180 is less than x is less than 270, find the value of the other 5 trig functions. So we need to find cosine, tangent, secant, cotangent. And they told me the sine was negative 3/4, so I automatically know the cosecant is negative 4/3. what's all that stuff mean? What does 180 less than x less than 270 mean? That's quadrant 3. So I'm going to draw my triangle in quadrant 3, because here's 180 and here's 270, so my angle is somewhere in between. And the sine is negative 3/4. What's my adjacent side? I don't think it's √5. It's √7. Watch your arithmetic. 16 minus 9 is 7. Negative on that 7?
Yeah.
Or √7? Because we went left. So, cosine. Negative √7/4, which means secant is negative 4/√7 or negative 4√7/7. Tangent. It's actually positive because we're putting a negative over a negative. So it's going to be 3/√7 or 3√7/7. And the cotangent is √7/3. Everybody okay on that section? All right, now we're going to sketch. List the amplitude, period, vertical shift, phase shift, and frequency. Okay, here we go. So we're going to start with our y equals 2 sine 1/3 x. Let's fill in all this information first. Amplitude, period, phase shift, that's horizontal shift, vertical shift, and frequency. And then we will draw a picture of it. So here we go. What do you know? What can you fill in here? Amplitude is 2. Which means when I sketch this, I'm going up 2 and down 2. Twice as tall as a normal sine curve would be. All right, what else do we know? Period is 2 pi divided by 1/3, which is 6 pi. Right? Which automatically means your frequency is 1/6 pi. Remember, they are reciprocals of each other. And write that 1/6 pi. How about these guys? Do we have any shifting in this problem? Are we going anywhere sideways or up and down? No, because we do not have a plus or minus in our problem. So these are zeros. Or you can write the word none. We don't have any. So this is a sine curve, a regular sine curve, that's starting where it's supposed to start and ending 6 pi later. That's what period means. One hill and one valley. So you need to label this thing, which would be 3 pi. You need to label this, which is called the maximum of the curve. You need to label this, what would that be? 1.5 or 3/2. And you need to label this, which would be the minimum of this particular curve, and that would be what? Exactly, it's midpoint. You want the midpoint of 3 and 6. So 3 and 6 is 9 divided by 2 be 4.5, or I'll just write 9/2. But yeah, 4.5. That wasn't so bad. I think the next one's going to be a little more complicated. Let's look at the next one. right, let's list all of our stuff first. Amplitude, what's the amplitude of this curve? Okay, watch it. It's 1/2. Yep. Now what does the negative tell me? The negative tells me that my cosine is going to be upside down. So normally my cosine with one period would look like this. This one is going to be upside down and look like this, because it has a negative out in front, and that's what negatives do. They reflect across the x-axis. What's my period? Yes, it's 2 pi over 2, which is pi, which means my frequency, I got a little out of order here, but that's okay. Frequency is going to be 1 over pi. Now what about a phase shift? Pi over 8, and that's a positive pi over 8. We are picking this picture up and moving it so that it starts, instead of at 0, instead of starting here where it's supposed to start, we're shifting it over so it's going to start here. What about vertical shift? We do not have one because there is nothing added. There's no like +1 or something at the end, right?
Is phase shift always with X?
Yes, phase shift is horizontal, so that's sideways. Phase shift is horizontal shift. So that's going to come from what's attached to X. Added or subtracted, I should say. All right, it's about time to go, but I want to finish this one. So this distance is how far? How far from here to here? You told me. You said the period was pi. So how will I find this point out here? Add pi. I start at 1/8 and add 1. So I would be at 1 1/8 or 9/8. This is the middle, the midpoint of 1/8 and 9/8. What is in the middle of 1 and 9? No, 1 plus 9 is 10, divided by 2 is 5. 5 is right in the middle of 1 and 9. You are averaging. Add and divide by 2. So 1 and 5 is 6, divided by 2 is 3. And 5 and 9 is 14, divided by 2 is 7. And that picture is done. And this is where we'll pick up tomorrow. Do I see you tomorrow? Yes, indeed. All right. We'll pick up here tomorrow. Remember, homework is due tomorrow. If you haven't turned it in now, it's due tomorrow. That's okay. You know what, my butt?